So to elaborate what we just learned, if this is the limit, somebody said, why really plug in numbers and do any of that? Start right away with, take 2x minus 5 minus the 3. Your goal is to get out of it an x minus 4, because that's the only thing. When I say give me a number close to 4, you could choose the number to be as close to 4 as you like. And in case you're wondering, how come I didn't choose the number very, very close to 4? Because then you have to create the machinery that could do that, and the more precision, the more expensive. You just want to create exactly what's needed. Do you see that I could factor a 2 out of those? Remember, I can control this, right? If I want this to be less than epsilon, which is what the definition says, they want this to be less than, oops, that's a bit too much. There, less than epsilon. So I start with that. Since I can control this, and this I call delta, right? Can you guess how this is going to play? I want delta to equal whatever that is. So, for example, just the last example I'm going to do, if I want it to be away from this by 0.008, according to what I just found, take 0.008 divided by 2, that's 0.004. So if this is 4, either go by a 4.004 above 4 by that much, or below 4 by that much. And if I plug this in my calculator, guess what will happen? If I take 4.004, enter. If I take twice the answer minus 5, I will get 3.008. And if I go below, if I go in and say 3.996, and if I take 2.992. Now, notice, if I take the absolute value of 3 minus 3.008, guess what I'll get? And if I take 3 minus 2.992, that is negative, but since it's an absolute value, and that's how it works. So what do you have to do on every problem? Basically, on every problem, you're going to have to do the following. You're not going to like it in the beginning, but you're going to get used to it. This work, you're going to really hide. You're going to do this work on every problem. We're going to work backwards on those, which is kind of cool. What you're going to say, you're going to start every problem by saying, anywhere you say prove, given epsilon bigger than 0. You could use this symbol instead. I'm going to move this to the left because I want this to really run down one shot. There is a delta bigger than 0, such that, instead of such that, you could use the notation such that whenever absolute value of x minus 4 is less than delta, and you're going to set delta equal to a value every time. In this case, can you guess what we're going to choose? We're going to choose epsilon over 2 because I already did this work. We have, and now you're going to let it flow. Absolute value of f of x, whatever this is, minus this. Your goal is to do the work and get an epsilon out of this, which is what the definition says. Now, let's make sure you're solid clear on this. This is less than 2 times what? Do you see this here? Is this here? Isn't that less than delta? And didn't we choose delta to be epsilon over 2, which equal epsilon? Therefore, the limit as x approaches 4 of 2x minus 5 equals f3. That is your official proof beginning to end. This part. That part is not needed. I'm not talking about this, I'm talking about this. So, let's do another one. Here we're not going to illustrate. Let me fix that. Alright, I'm looking at number 20 and here it is. So again, I'm going to go on the side and figure this out. I'm going to say 3 minus 4 over 5x minus a negative 5. Keep in mind, I have control over x minus 10. I want an x minus 10 out of this. If I get a common denominator, actually before I get a common denominator, isn't that an 8? Is that right? Yeah. And if I take O over 5 minus 4x plus 40, do you see that I could take a negative 4 over 5 and I'll have an x minus 10 out? An absolute value of a negative is a positive. So this is the key. I have control over. When I say give me a number close to 10, you could choose it to be as close to 10 as you like. I want this to be less than epsilon. Set it to be less than epsilon. And solve it. That means if I choose this to be less than 5 epsilon over 4, which is my delta, I'm in good shape. And when I do that proof, look at that now. Now I say, given, if you give me any epsilon, any small number, no matter how precise you want this to be, given epsilon bigger than 0, there exists a delta bigger than 0 such that whenever absolute value of x minus 10 is less than delta, which will equal, and guess what we're going to choose it to equal? Whatever precision they want, we're going to take that and multiply it by 5/4, 1.25. So this is not that precise. We have, and we start with the official definition, absolute value of f of x, 3 minus 4 over 5x minus a negative 5. Basically, you're going to reiterate that. And that's going to be absolute value of 8 minus 4x over 5. That's going to be 40 minus 4x all over 5. That's going to be 4/5 into negative 4/5 into x minus 10. And I'm going to say that is 4/5 absolute value of x minus 10. And I'm going to take this out. By taking this out, I am able to say this is less than, because delta is bigger than that. Delta is always bigger than that. Right there. And that's going to be 4/5 times, and what did we say? We said we want that to be 5 over 4 epsilon, and that would be epsilon. And therefore, the limit as x approaches 10 of 3 minus 4/5 x equal a negative 5. That's the official proof. And when you're done, you're supposed to erase all of this. I really don't mind if you leave it, but that's not part of the problem. The proof is actually right there. This would be the official proof, beginning to end. Alright, next problem up, number 30. If I go on the side and try to figure this out before I start, I'd say, well, let's see. It's going to be f of x minus the limit. And here we're going to start with given epsilon bigger than 0, there exists a delta bigger than 0 such that whenever 0 less than x minus 2, so I need an x minus 2 out of that. That's the only thing I can control. I'm going to set that less than delta, and I'll choose what that delta equal in a minute. So that's how it always going to work. I can only control x minus 2. So let's see how that works. X squared plus 2x minus 8, and that would be x plus 4 into x minus 2. Well, x minus 2 is right there. I can control that. I could put a delta there, but there's a problem. So I could play along and say, you know what, put a delta there. But that's not a number. To say this is less than epsilon, so for delta, well, what am I going to do with that x plus 4? I can't control x plus 4. I can only control x minus 2. So what I do, I'm supposed to pick a very small number. Delta is very small. I'm going to choose 1. The book does that just to make this numbers run smoothly. You should be choosing something like 0.0001. But let's say it's a 1. And x is between 3 and add 1, a 1. So basically, when I say give me a number close to 2, you wouldn't say 3. You'll say 2.0001 or 1.999. But we're going to choose 1 just for simplicity, to keep the numbers running smoothly. So I want this to be as large as possible. So 3 is the biggest. X plus 4, the biggest this could ever be. The largest value it could ever have. If I let x equal 3, that means 7 delta equal epsilon. So if I choose delta to be epsilon over 7, I'm playing it safe. Right? Epsilon over 7. And now if I play this game, let's see how this works. Forgetting all of this, I'll take x squared plus 2 plus 2x minus 7 minus 1. That is x squared plus 2x minus 8. I just did the work right there. You could just copy it. X plus 4 into x minus 2. I'm going to say this is less than. The biggest this could ever be, if I put a 3 there, is a 7. So 7 is bigger than x plus 4. And I'm going to say this is less than, guess what? My delta. And what does delta equal? Delta equals epsilon over 7. So I have an epsilon. So I took f of x minus L and I got it to be less than epsilon. Therefore, the limit as x approaches 2 of x squared plus 2x minus 7 equal 1. There's a small catch. Since I chose this and I chose this, I have to include that here and say let delta equal the minimum of those two. The smallest of those two values. That's the only catch. You have to do that every time. Okay, I'm out of time. I wanted to do one more problem, but I don't think I could do it in that time. I'm just going to write it down and you could see it. And I have just worked out problem number 28 for you, and there's the homework. If you have questions on that, just ask me in class, and that's the work, and we go from there.